We united two competitors in the same factory in Germany. As part of our Made in Germany series, friendly competitors Thermal Grizzly and Watercool gave us a tour. Der8auer from Thermal Grizzly drove us to his competition, a factory from Watercool.
First question, why does Germany make so much water cooling?
We are the German water cooling mafia.
We have also brought, technically, your competition.
Yeah.
Der8auer.
Well, I technically brought you to my competition.
Yeah, that's true.
And even though these two are competitors within just 2 hours of each other, they can still laugh over a common obsession.
I love machines.
Yeah, that's a good answer.
We share a similar problem.
So, one of the things that Watercool makes is this. Rico, what is this?
Yes, this is a MORA-600, our biggest radiator now.
We even managed to accidentally facilitate an impromptu swap meet for machines between Der8auer and Watercool founder Rico. I should have asked for a commission.
This for sale.
Oh, you're selling it?
Yeah, how much? Yeah. So 5,000.
You gonna make a deal?
But it's for bigger parts, but it's all mechanical.
Yeah, we have the same. Just
Yeah.
But do you need another? You need another one, though, right?
We were considering getting another one.
I think you probably need another one.
that would be absolutely hilarious. Like,
He'll give you a special price.
Yes.
Yeah.
$499.99.
As the final installment, for now at least, of our Made in Germany series, we visited
Waren.
Waren. Okay.
Waren Müritz.
In Germany.
Yeah.
About 2 hours north of Der8auer.
Let's check out the Watercool factory with friendly competitors Der8auer of Thermal Grizzly and Rico of Watercool. Before that, this video is brought to you by the Fractal Momentum series fans, including the Momentum 12, 12 RGB, 14 and 14 RGB, and 120 and 140mm sizes. The Fractal Momentum series fans performed excellently in our review of the Fractal Meshify 3 case previously, but can also be bought separately. The RGB options use the softer accented outer ring lighting that we praised in our review of the Meshify 3 case. The fans use high quality LCP blades for a higher performance operation, and you can learn more at the links in the description below.
Roman, have you been here or no?
No. It's also the first time for me. It's also very interesting.
This is the milling area, and here we make the sheet metal parts.
That's cool.
Yeah.
Wow. Yeah.
That's a German machine.
Yeah, that is a crazy one.
That's the punching process, and later we see the laser process.
Yeah. What part is it actually cutting on the, do you have a finished one we could look at? A finished grill?
Yeah.
Oh, right here.
Yep.
That's nice. So this is what just came out of there.
You see, that is so you can flip these parts in or
Right.
outwards, and then they will form a connection on these angles.
What does this big arm do?
That helps the worker to put the sheet metal on the machine.
So is this just suction cups?
Yeah.
And so then what are the steps for him to get it from the racking to the machine?
The first step is just take the forklift, get the material out from the storage, and then because of the suction vacuum thing,
Yeah.
they can take these individual 1mm steel sheets and then easily carry it into the machine and place it in there. And the machine then can move it by itself.
Okay.
Like the machine will grip it and then move it by itself wherever it needs it to be.
Is it punching 6 drills for one sheet or something?
Yeah.
So what's back here for the machine? Is this all?
Steering and a suction unit, and in the back you see the laser, the fiber laser. And the fiber optic moves the laser into the machine.
Okay.
The laser can cut 20 millimeters of steel, but not on this machine. It's for thin sheet metal.
Just for some context, this laser has about 30 times more power than the one you saw at our office. So yeah.
What is it doing right now? Because it looks like it's changed.
Countersinking.
Oh, okay. That's for all those screw holes, I guess.
Yeah.
Do you have to get tools special made to put on the end of the machine?
Yeah, the tools are in the back of the machine. Yes,
Not
it's changed.
I think what's also interesting is that the nitrogen supply part. So when the laser is cutting, then there has to be a constant flow of nitrogen gas, and that is for to prevent oxidation and stuff not going on fire, and also to push the liquid steel downwards.
Do you need anything to keep the machine cool?
Yeah, it's water cool. No?
How many MORA-s do you need?
Yeah. So that's your countersinking.
Yeah.
That's all the punching it was doing?
Yeah.
Okay. And then is the punch tool, is it just shaped like this?
Yeah.
Oh,
Yeah.
wow.
Yeah.
Okay. It just.
It is.
Okay, cool. And then what was the laser part? Was it this?
Every outer edge cut.
Got it.
The outline is cut by laser.
Yeah.
Yeah.
Should we look at the bending?
Yeah. It's a cover from the HTF2 radiators, the smaller. We need them for industrial customers. We have projects with Volkswagen, Audi, and we have worked with GM.
We have a bending machine,
Yeah.
but it's like the baby version of this.
Sure. Is this the type of thing you want to grow into for your factory?
I'm not sure. I wish, but like we're not specialized in this type
Sure.
of manufacturing. It's nothing we're aiming to do, and I think they're just much more specialized in this, which I think is great.
So this is before. I'll let you hold it.
Yeah.
And
Before
then-
cut on that machine,
Yeah.
and then after bending, it's this.
Right. And then how does this install?
Yes.
On
Then
here?
It's a cover from
Okay.
this side.
Cool.
Yeah.
I think looking at the bending process, it seems very straightforward.
The accuracy, it's very important to get parts that we can use it for the production.
For the sheet metal stuff, I can just say that it's also difficult just to make it. You know, if you want to do a 90-degree bend, it's not 90 degrees in the machine. But
Yeah.
you have to bend it a little bit further
Over.
because it will move back and all
Right.
that. There's a lot of things you have to keep in mind. Yeah.
What's the next step after this stuff?
Schleifmachine, surface grinding.
Sometimes there is art, I don't know.
Yeah.
It's like a sharp edge.
Sharp edge,
The
yeah.
bottom is protected by the foil, so
Yeah.
it doesn't scratch. But on the top side, you might have this, so you run it through to just remove that.
Okay. All right.
Yeah, please close the door.
So he loaded something on the backside?
Yeah.
Is that it? Is that fast?
It's that fast. Yeah.
Very efficient.
Yeah. It also gives it this nice brushed look.
Yeah.
And you can see like before and after, if you touch this, it's very sharp.
Right.
And if you now go here, there's like no more sharp edges anywhere. And that's within seconds.
That's impressive.
If you grinding steel and aluminum and you don't have the suction unit, it can blow up.
It can ignite. It's like with
Yeah.
flour, you know.
Yeah.
Actually blow up.
Yeah, it can actually blow up.
Not
Yeah.
just like break.
No,
Okay.
because you have the dust in the air, and if there's like too much of it, and you have a spark somewhere, then
The
Yeah.
whole thing goes up.
metal burns much
Yeah.
better than people think.
Yeah.
What are the types of things that, in terms of getting someone who's skilled, right? Like skilled and good at
Yeah.
machining, like working on this machine or that
Yeah.
machine. What makes a person good at being a machinist in this type of environment?
Our
Meister.
Yeah, it's a specific, if you're in Germany, if you learn your job, the first thing you do is the apprenticeship. Takes like 3.5 years for the type of job. And then once you specialize, it's like studying. It's like an extra thing on top, and that's what he's. So he's very qualified for any metal works.
Okay. When did he start working with you?
2005.
Wow.
Yeah.
Cool.
Almost 20 years.
One of our oldest members.
Danke. So, CNC area. So, and I only see one guy over here. Do you basically have one person manage all the machines?
Yes.
How many machines is it?
We have 8 machines.
So one guy can manage 8.
Yeah.
That's pretty cool. All right.
Are they all the same machines or different ones?
Slight differences. And we have machines with 3 axes and 4 axes. Yeah, that's the main difference.
So for your operator, for the person who's managing all the machines, what do they normally do? I mean, they obviously keep them running.
Yes.
But what does keep them running mean?
Yes, you have checked the tolerances, the quality of the surfaces, the measure of the parts, and you have prepare the machine with the right tools and check the tools and make little adjustments on the CNC programs. All parts from Watercool are made on these machines, GPU blocks, CPU blocks, cooling plates, tanks, whatever.
So if we come over here, and these are GPU blocks.
Yes, these come from this machine. It's the backside from the Strix cooler.
Ah, yeah, looks nice.
Yeah, the front side is crazy.
Yeah.
I like the machining path looks really
Yeah.
cool. Yeah, it looks really good.
How long does it take to machine something like this?
So I think 15 minutes to start, and that's the end.
So he's mounting it to the fixture, I guess?
That's a classic to protect the finished side.
Okay.
And that is a vacuum indicator.
Yeah.
So when he starts, it has to go down. Otherwise, you know, it wouldn't keep it, right?
Yeah. So Roman, you said you use, was it like ethylene or something, and alcohol or
Yeah, just ethanol, yeah.
ethanol?
Yeah.
And then are you guys oil-based for your CNCs?
Yes, it's a water-oil mixture.
What are the pros and cons? What are the advantages, disadvantages for both of those?
I would say the pro of oil water is that you can use any tool. Like you're not limited in tooling. You have the best possible cooling.
Yeah.
You also get better surface quality, especially when you have like the diamond cutter. So overall, it is the better in terms of manufacturing. But you need extra steps afterwards to clean the parts. Yeah, that's mainly it.
Okay.
Yeah, that's all the fixtures for different parts you're making. If you have a cold plate and you somehow need to mount it in the machine,
Yeah.
right?
Yeah.
And then usually for every single part, you need to make a fixture to clamp it down, clamp it from the side, rotate it, whatever.
Do you make the fixtures yourself? You make
Yes,
them here?
it's all from our
Do you
side.
make them on the same machines?
Yes.
So then how do you hold the fixture?
Yeah.
When you make you can use a fixture
You can use a vise.
Okay.
This is a picture plate for MORA tank. For the cover. It's a vacuum fixture.
Yeah, just have one bolt to assigned orientation.
Yeah.
This one is for a longer version of this. And then it's like by these 3, it's oriented, and then it's just hold down by the vacuum and sealed over the ring.
Cool.
And then you can like easily mill the edge. Yeah, that is one difference. So they work with this type of long copper and then cut it to shape and do the individual parts. That's where you saw we were doing like the plate material. So it's a completely different concept.
Right.
Yeah.
Out of all the materials you work with, what tends to be the most expensive per area? I guess, is it copper or?
Yes, it's
Okay.
copper.
What we're now getting for trash, like copper trash, was the price that we paid new a few years ago.
Oh, wow.
So it's like
Okay.
it's basically doubled over a few
Yeah.
years.
Yeah.
He said there's something cool in the backside.
Okay.
So apparently they engineered something with their own tools.
And we use our own products on this machine.
Oh, on the back side.
Yeah.
What's normally back there?
I think it's a self-made thing.
Nothing.
He said that for the vacuum fixture, they're also sucking in the coolant. And this is a self-made design to separate the coolant while still maintaining the vacuum.
What is all of this?
This is a dust junction unit to clean the air.
It's the mist that is collected from the CNC mills that contains residues from oil.
Yeah.
And it has to run through it before the air can be dumped out.
Yeah, I see if you follow these tubes or the ductwork, they just attach to the top of each machine, I guess.
Yeah.
Cool. Upstairs?
What do you do the packaging?
You were saying something on here is a prototype, I guess. Yeah, I saw that. I saw it.
What, did you touch it with your filthy hands?
Yeah.
No, no. Yes, this is a prototype from our active control. With the active control, we can control the fan speed, the RPM, the pump speed of 2 pumps. We have a level sensor built in. We have
Thermometer, I guess, right? Temperature.
temperature measurement and flow measurement. Yes, all in the small control unit. Can easily move. So
you got 4 200s on here.
yes, and can change.
Nice.
We have a cable management on this version.
When did you guys come up with the Mora? When did you originally start selling it? Because it's been around a little while now. So
Yes, yeah, it's the first version. It's I think 2005 or 6. It's
was that your
very
design?
time. The original idea came from another German manufacturer, but he gave up and say, take it and
Okay.
make it better, and we make the Mora version 2, then the 3, and this is the 4th.
Does it stand for more radiator?
Monster radiator.
Monster radiator.
Yes,
Okay. What about the machines up here? Because you got a couple things upstairs.
It's our cardboard cutting machine. We produce special packaging here in-house, give us more flexibility. It's a knife, very sharp knife that cuts cardboard.
So in some spots where you want to bend it, you just slit it, like not cut through,
Right.
but just run through the surface that you have an edge for the bending.
It's like a pizza cutter. I mean,
Yeah, yeah.
Does the machine do these
Yes,
perforations
yeah,
also?
yeah,
Okay.
yeah.
And your supply is local?
Yes, we use the cardboard from a local producer, and it's around 500 meters from our factory.
Very
So you
convenient.
carry it
Great.
over.
Yeah, yeah.
I guess if you run out, it's not hard to go fix it. So.
Yeah, yeah.
What about this?
Yes, here's the printing system.
So that's actually just doing the text.
Yeah,
All right, so then last room, I guess, was the packaging and
assembly.
Let's
Yeah.
do that. It's a lot of Moras.
Yes. Here's our shipping area. Here are the packaging for the orders around the world. Yes, here we have our laser engraving machine. The most parts are engraved with serial numbers, logos,
Yeah.
or special things.
It's a part for the MORA control, I think,
Okay.
and it's a POM, so POM acetal part, and using a fiber type laser. And then, because the cool thing about that material is if you have the right laser and engrave it, it becomes white.
Here's the assembly area for GPU blocks and CPU blocks.
Okay.
Every part is leak tested.
Are the blocks that have RGB LEDs more of a pain in the ass to assemble?
I think so.
But it looks much better.
Yeah,
I mean,
looks
this looks really good. Yeah.
These are Threadripper base plates.
What's the Threadripper volume like these days?
Oh, it's better than before. Now with the new generation, the cells go up. Here we have the radiator assembly. All radiators, all types, all sizes were assembly here in this area. This is MORA 400 core.
So this is before you put all your stuff on that we just
Yes.
saw getting made.
Yeah, yeah. Assembly time from scratch about 30 minutes.
Okay.
Yeah, for each MORA radiator.
And what's involved in assembly?
I think it's mainly screws. Like you have all the threads already on this,
Yeah.
and then you get all the pre-made parts that they prepared, like bent, powder coated, and then they all go on all the different edges, like 4 sides, and covers, add wiring if needed.
Right.
But it's mainly just screwing in, like everything is pre-threaded at that point.
So I see like an air supply.
So it's for riveting, if they rivet. Yeah.
What types of stuff gets riveted normally?
Industrial radiator for industrial use.
Right.
Yeah.
How much like industry versus normal customer?
Half and half, I think. Yeah. Yeah.
This is just a giant radiator that they've custom bolted to the desk.
Yeah, I spotted some tubes exiting the system here.
Yeah.
Because I just talked about, Fantex Evolve being a
hot box.
hot box.
Yeah.
But then I saw this. It's like, where are the tubes going? And then it just goes into the desk.
So there's the tubes, and then those are just going into a big radiator.
The last stop of our tour is where they actually do the engineering, the computational fluid dynamics, mapping the flow path, the resistance for the water, and how the block will actually perform.
You can model a graphics card with electrical parameters, GPU, RAM, VRAM, all things.
So everything you want,
It
basically.
needs time.
Yeah.
You can choose the right materials and thickness and simulate a complete graphics card.
What are you looking for in this?
Like for example, a bad turbulence, like this one. This is okay, but when you're designing a block, you maybe have a dead spot, what's not so good, where air get trapped. You want to make it easier for the first loop that it is cleaned up. So the air out pretty easy. Blue means pretty slow, and the more it gets green, and the faster it gets.
You can see everything that's entering directly in the center is like green because it's very high velocity in the center.
Oh, okay.
And then once it's going through, you can see it's just slowing down afterwards.
Right. Cool.
That's the tricky part about making a block. So you have to find the right balance of surface area and like how narrow can you maybe make the jet plate to accelerate this? How high does it have to sit? How high do you make your fins?
Right.
All those parameters go into, I would say, making the perfect block. Theoretically, of course, if you have like unlimited pump speed, then you would come to a different conclusion, but you would try to find like a realistic scenario with a realistic flow rate.
So you design for a standard pump, I guess.
Usually, yeah.
Assuming, yeah. How long does it take to actually simulate?
If you want, you can set it up, and it will take 1 week, 2 weeks with this machine.
We are not the fastest at the launch.
But when you're done, it's done.
When we're done, it's done.
Yeah, no, that's a good philosophy, yeah.
That's it for our tour of Watercool in Germany as part of our Made in Germany series, where we featured Roman's factory for Thermal Grizzly and Watercool's factory now, joining our lineup of in-depth factory tours and educational deep dives into how the stuff that computers use is actually made. As always, we fully pay for all of these trips ourselves, so we don't accept sponsorship money from the companies that we're covering when we go to film their factories. If you'd like to help us fund our next trips for the next educational factory tours or similar videos, you can go to store.gamersnexus.net and grab something over there. Thanks for watching, subscribe for more, and we'll see you all next time.